All right, let's get right into it. Today, we're going to explore the absolutely incredible vision of physicist Michio Kaku charting our future out in the cosmos. We're talking about a journey that won't just change where we live, it's going to change what it means to be human. This quote really sets the stage for everything we're about to talk about. It comes from Konstantin Tsiolkovsky, one of the pioneers of rocketry. And it nails the core idea, right? This fundamental need to push outwards, to see what's over the next horizon. So, if we have to leave the cradle, that's the billion-dollar question, isn't it? This isn't just a trip to a new place. It's a journey that will take us to completely new versions of ourselves. Okay, let's dive into this. You know, to figure out where we're going, you really have to look back at how we got started. And believe it or not, our incredible journey to the stars didn't begin with some huge explosion, but with a dream, one that was literally inspired by science fiction. Our first big steps were really this amazing mix of wild imagination and fierce competition. It kicked off with visionaries like Robert Goddard, who actually read H.G. Wells' War of the Worlds and got inspired to build the world's first liquid-fueled rocket. But the real catalyst? The Cold War. When the Soviets launched Sputnik in '57, it sent a shockwave through America, leading directly to the creation of NASA. And the grand finale, just over a decade later, was that historic first step on the moon. So after the huge high of the Apollo missions, things kind of slowed down. Public interest just wasn't there in the same way. But right now, we are living through a brand new golden age of space travel. And this time, the race has some very different and very, very ambitious players. The next giant leap for humankind is Mars, no question. But there are two very different schools of thought on how we get there. On one side, you've got NASA with its steady, methodical, government-funded plan. Let's go back to the moon first, use it as a staging ground, maybe build a new space station in lunar orbit, and then aim for Mars by 2033. But on the other side, you've got private companies like SpaceX, who are just all in on a faster, more direct path, driven by this relentless focus on building an actual city on Mars. And their whole strategy hinges on one massive innovation. So what's the crucial point? Reusability. This changes everything. For decades, launching a rocket was like flying a jumbo jet across the ocean and then just throwing the plane away at the end. It was unbelievably expensive. But by creating rockets that can literally land themselves and be flown again and again, SpaceX has completely upended the economics of space travel. It's what makes these dreams of moon bases and Martian cities feel real and actually possible for the very first time. Okay, so we're getting our act together for Mars, but what comes after that? What about the truly mind-bending journey to a whole other star system? Well, that is a challenge on a completely different level. Our current rockets, even the fancy reusable ones, just can't do it. They're trapped by what's called the rocket equation, and it's a real catch-22. To go faster, you need more fuel, but more fuel adds more weight, which means you need even more fuel just to lift the fuel. To get to another star, the fuel tank would have to be bigger than anything we can imagine. We need a totally new way to fly. And this is where the solution gets, well, it's kind of beautiful in its simplicity. Instead of carrying your engine and fuel with you, what if the engine stayed right here on Earth? That's the whole idea behind nanoships. They're these tiny, wafer-thin robotic probes attached to a light sail, and you just push them through space with a giant, powerful laser from home. And get this is not just some sci-fi fantasy. It's a real project called Breakthrough Starshot. The plan is to launch a whole fleet of these little explorers and then blast them with lasers until they hit 20% of the speed of light. Now, at that incredible speed, they could reach our nearest stellar neighbor, Alpha Centauri, in about 20 years. Think about that. A journey that would take our fastest rockets tens of thousands of years, done in our lifetime. So we're figuring out how to zip around the solar system and even how to leap between stars. But that brings up a much deeper, maybe even more important question. Once we get to these new worlds, how do we survive, and what do we have to become? The places we find out there are not going to be Earth 2.0. We could be dealing with crushing gravity, deadly radiation, atmospheres we can't breathe, you name it. To survive, the idea of transhumanism, literally upgrading our own bodies with technology, might stop being science fiction and start being a survival guide. So, what's in the toolkit for the space colonist of the future? Well, how about strapping into a powered exoskeleton so you can walk around on a high-gravity world? Or what about using genetic tools like CRISPR to literally build radiation resistance into our DNA? And for the really dangerous places, why risk a fragile human body at all? Maybe we just upload our consciousness into a super durable robot avatar and explore that way.
This is how we might become a post-human species, able to adapt and thrive anywhere in the universe.
So let's zoom all the way out. If humanity pulls this off, we colonize other worlds, we evolve, what's the end game? What does a civilization that has mastered space even look like? Well, as it turns out, someone came up with a way to measure that. Back in the 60s, an astronomer named Nikolai Kardashev came up with this brilliant cosmic measuring stick. He figured that a civilization's power is fundamentally tied to how much energy it can control. The more energy you can harness, the more you can shape your own destiny. So, where are we on this grand cosmic scale? Brace yourself. We're not even a Type 1 civilization yet. We're currently rated at about a point 0.7. We're still mostly burning fossil fuels, dead plants, and we haven't even come close to capturing all the energy that our own sun beams down on our planet every day. Cosmetically speaking, we're still infants. But the path forward is pretty clear. A Type 1 civilization has total mastery over its planet's energy. A Type 2 has gone way beyond that, capturing all the energy of its home star, maybe by building a colossal structure around it called a Dyson sphere. And the final step? A Type 3 civilization, one that commands the power of an entire galaxy.
But even a civilization that controls billions of stars has an enemy it can't defeat: time itself. The universe has an expiration date. It will eventually grow cold and dark in what scientists call the Big Freeze. So, what's the last move you can make in this ultimate game of survival?
And this is where things get truly wild. To escape the death of the universe itself, you'd need the ultimate lifeboat. The theory goes that a Type 4 civilization could harness so much energy it could punch a hole in the fabric of space-time, create a wormhole, and escape into a younger, warmer universe. And that just leaves us with this one final, staggering thought. If a civilization becomes powerful enough to escape our universe, could it become powerful enough to create a new one? It's an incredible idea, but it suggests that maybe, just maybe, humanity's ultimate destiny isn't just to be explorers of the cosmos, but to one day become its architects.